All right, so the zero product property is the idea that if we multiply a number by zero, it's always going to end up being zero, right? So, for example, right, if I take 7 times 0, it's going to give me out 0. So ultimately, no matter what this number 7 is right here, okay, doesn't matter what that is. It could be 9, it could be 100,000. If it's multiplied by 0, we're always going to end up getting out 0, okay? Now, we can use that to our advantage because when we're talking about polynomials, frequently we'll have something where we're in factored form. So factored form looks like something like this, right? And we might say that we want to know what x values I can plug in to make the whole equation be equal to 0, right? So essentially, right, if I can make either one of these factors be equal to 0, then the other one will become, or the whole left side, sorry, would become 0, right? Because I would take 0 times number or number times 0. The best way I can describe this is, let's see what happens when I plug in -1, right? So if I plug in -1, I've got -1 plus 1, and then -1 minus 3, right? Now, simplifying a little bit, -1 plus 1 is going to be 0, and -1 minus 3 is going to be -4. So 0 times -4 does, in fact, equal 0, right? So this value right here, -1, is a special value because we can plug it in for x, and it makes the whole equation be 0, okay? Now, if we have a value, or we've got a factor where there's no number in front of the x, then it's remarkably easy. We just take the opposite of what we see there. So I see x plus 1, so my factor must be -1, right? Or I see x minus 3, and you can check this if you like, but my other factor must be +3, right? Because if I plug in +3, right there, 3 minus 3 will be 0, and 0 times whatever number I have left will give me my factor. Now, for each factor that we see, right, factor is sort of little parentheses here, so x plus 1 is a factor, x minus 3 is a factor, and more specifically for each x that we see, we're going to have a 0, or this is what we call a root, that will work to give us a true statement, right? Essentially, it'll evaluate to give me 0, okay? Where this gets a little bit tougher is when we add in numbers in front of the x's, so something like 7x plus 1 times, I don't know, 4x minus 9, okay? It's not so easy as to say, well, it must be -1 here and +9 here, because we've got these numbers in front. So if I plug in 9, then I would have 4 times 9 minus 9, which is not going to be 0, right? But what we can do, okay, is instead say, I want this whole factor to be equal to 0, right? Or I want this whole factor to be equal to 0. In either of those cases, whichever x's make that happen, we're going to end up with a true statement where when we solve it out, we'll get that the left side is equal to 0, right? And so I can use something that we learned very early on in algebra. I can say 7x plus 1 is equal to 0, right? I can solve for x, aka I subtract 1 from both sides, and then I divide by 7, okay? And that right there is one of my two. So if I try and plug in -1/7 right here, -1/7 times 7 would be -1, and then -1 plus 1 would be 0, thus making this first factor actually be equal to 0, and 0 times whatever the other one is, it doesn't matter if it's a number or not, it's still going to end up being 0, right? So we can do the same thing for the other one. Oops. 4x minus 9 is equal to 0, right? So we add the 9 over, we divide by 4, and we get x equals 9/4. So these two would represent our two roots, one for each of the two x's that we see, okay? So this is the idea of the zero product property. So if you're asked to find the roots, right, what you're being asked to do is to take a polynomial function of something like, I don't know, 7, right? To take a polynomial function, to set it equal to 0, and to solve for the two values that make that the case. So in this case, x equals 3 and x equals -7. These right here would be our two roots. All right. Hopefully this was helpful. Do let me know if you have any questions.